Okay, hi all. Good evening. So today we'll start science. Is my screen visible? The screen is visible?
Yes, sir.
Okay. So we'll start with the chemical reactions and equations. Can you tell me guys what is the meaning of chemical reaction?
So
What is the meaning of chemical reaction?
we mix two or three substances chemically
Hmm.
and then
We
we
make two
obtain
or
a
three
result
substance chemically. Okay.
and then
Uh-huh.
we obtain a result including
ठीक है.
these two.
Correct, correct, correct.
Products form form or sorry, two or more reactants form or
Hmm.
products.
Okay. There will be some reactant and some products, right?
Yes, sir.
Yes, sir.
Okay. Okay. Can you give me some day-to-day life of chemical reaction? Daily life में कोई chemical reaction का example, any
Sir,
reaction, any example from your daily life?
milk when milk
Very good,
fermentation,
very good. Krishna has given a very good example. Milk is getting
respiration,
converted into curd. It's a good example of chemical reaction, right? Okay,
respiration,
good.
sir.
Respiration is also good. Then, when you dissolve surf detergent in water, is that not a chemical reaction?
Yes, sir. But it doesn't give any products, right, sir?
It doesn't give any product, but it's not necessary. But like the water is getting heated, right? And you're getting some
Steam.
foam,
Yeah, yes.
right? That's also an example of chemical reaction. Any other example?
Any other example?
So water is chemically combined of hydrogen and oxygen.
Okay.
Burning of coal, sir.
Burning of
When,
coal.
yeah, when coal is burned, carbon dioxide is released.
Sir,
Okay.
and then
Any other example?
rusting of iron.
Rusting of iron. Very good. दिव्या, आप बताओ कोई chemical reaction का example from your daily life? Hello, Divya, can you hear me?
Yes, sir.
कोई chemical reaction का example from your daily life?
Sir, photosynthesis.
Photosynthesis. Very good. Photosynthesis is also a good example of chemical reaction from our day-to-day life, right? Okay.
Sir,
Good.
slow oxidation of oils and fats of food
Slow
items.
oxidation of
Like
oils.
when the
Hmm.
oils of food is left for more time, so the
Mhm.
smell and the taste of the oil will change.
Okay. That's also an example, right?
Yes, sir.
Okay. Okay. Good. Any other example?
For example,
Sir, rotting of eggs.
Rotting of eggs. Good. That's also a good example. When you add lemon in water, soda water,
Yes, sir.
that's also an example of chemical reaction,
yes,
right?
sir.
Got it? So these all are examples of chemical reactions.
Chemical
This is clear?
reactions. Yes, sir.
Okay, good. Now, today, same thing we'll study here. What are the examples of chemical reactions and equations? Consider the following situations of daily life and think what happens when my screen is visible to everyone.
Yes, sir.
Okay. Milk is left at room temperature during summers. If you will leave milk at room temperature during summers, what will happen?
Sir, eating like
Eating.
no.
दिव्या, अगर मिल्क को हम रख देंगे समर में तो क्या होगा? Hello. Yeah. If you will leave milk, okay, somewhere in the summer season, what will happen?
So will it evaporate?
Evaporate. The
Some
taste will be
kind
bad,
of taste.
right?
Okay.
Correct.
Yeah.
Right. It will not be fit for drink. So that is actually one chemical reaction is happening there. So if you see around us, it is full of chemical reactions. You apply paint on a wall, chemical reaction, right?
Sir,
In your
whitewashing, sir.
paint, whitewashing, example of chemical reaction, right? So a
Catch.
lot of such examples are there, chemical reactions. Okay. So the best example is if you leave milk during summer season, if you will leave milk on any table, so in another 3 or 4 hours, you will see that the milk will not be good to drink. Okay. So that's one example. Then an iron tawa pan nail is left exposed to humid atmosphere. Like Manaswani told the example of that rusting of iron, right?
Yes, sir.
You will see like sometime if you keep some iron bars or any other iron tawa, anything, okay, in humid atmosphere, it will catch rust. We have seen that.
Yes,
Okay.
sir.
So that's also an example of a chemical reaction. Is this clear? Is it making sense?
Yes, sir. So when
Okay.
Yes.
steel spoons are kept in salt or any other chemical, then like they'll be disappearing after some time.
Correct. Yes. These are
Or
examples of chemical reactions. Yeah. Then grapes get fermented. This is also an example of chemical reaction. Is this clear?
yes,
So if
sir.
you'll see around us, there are a lot of examples of chemical reaction. Hope this is clear.
Yes, sir.
Any question?
No, sir.
Okay. दिव्या समझ में आ रहा है?
Yes, sir.
Okay. So that is what we are going to study today, the examples of chemical reaction. Food is cooked. When you cook a food, that's also an example of chemical reaction only. Food is getting digested in our body. It's a very beautiful example. The food which is getting digested in our body, that is also that's also a very good example of chemical reaction. And from that only you are getting energy, right? So if someone will ask you, okay, show me or tell me the real time examples of chemical reactions, you can tell this that the food which is getting digested, if you're eating something, we're getting energy from it, right? That's
Yes.
also an example of chemical reaction. Okay. Cooking. Daily your mother is cooking food for you. That's also an example of chemical reaction because a heat, with the help of heat, like that, chemical changes is happening in the food. And because of that, the food is getting prepared, right? Suppose you are preparing something like, let's say, some vegetable.
Yes,
If you
sir.
will just keep vegetables in an utensil, will you get some smell? You will not get it. Once
Yes,
you
sir.
start cooking it, then you will get some smell. That's also an example of chemical reaction, right? And we respire, we breathe. That's also an example of chemical reaction. So if you will look around you, a lot of examples are there for chemical reactions. It means our life is full of chemical reactions only. That's what we're going to study here. Is this
Yes.
clear?
Yes, sir.
So far clear, right? Okay. Now we will proceed further. Okay. So just a minute. Yes. Okay. These are the examples of chemical reactions. Now, in all the above situations, the nature and the identity of the initial substance have somewhat changed. Yes. Whenever a chemical reaction will take place, then the initial substance will change finally. When you're told that milk is getting converted into a curd, that's a chemical reaction, right? So initially it was milk, it is converted into curd. So the initial substance is getting converted into curd. That's also an example of chemical reactions? It means initially you have something, but finally it is getting changed into something else. That's example of chemical reaction, right? So in chemical reaction, what will happen? The initial substance will finally change. Is that clear?
Yes, sir.
Yes, sir, it's clear.
Okay. Somna, can you hear me?
Yes, sir.
Okay, from next class, I want everyone on video. Okay.
Okay, sir.
Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually mean by a chemical reaction. How do we come to know that a chemical reaction has taken a place? Has taken place. Let us perform some activities to find the answer to these questions. There are few activities from this we can understand that the chemical reaction is taking place. We'll come to this activity. We'll discuss about it. Okay, this activity one. This activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon. Okay, first of all, we have to clean a magnesium ribbon. Do you know the formula, the symbol of magnesium?
Yes, sir. Mg.
Mg, right? Mg is the symbol of magnesium. To clean a magnesium ribbon about 3-4 centimeter long by rubbing it with sandpaper. It means you have to take a magnesium ribbon of 3 to 4 centimeter long. That is what they're showing here. This is a magnesium ribbon. Okay. And you have to clean it with sandpaper. Have you seen sandpaper?
Yeah, yes, sir. We use it for removing the coating wood.
Yeah, scrubbing things which we can't with normal hands.
You have seen it. You have seen it, right?
Yes,
Yes,
sir.
sir.
Okay. Sumna, have you seen sandpaper?
Yes, sir.
Okay, you have also seen. Okay. Let me show you that. Can you see this?
Yes, sir.
This is an example of sandpaper. Sometimes we will see that laborers they use this sandpaper to rub on the iron rods. Okay, to clean the rust. So this is your sandpaper. Okay.
Okay, sir.
Okay. I think you all must have seen this. Okay. And even if you will go to some hardware shop, no, they can give you this for 5 or 10 rupees. If you will touch on top of it, it will be very rough. Okay, it will be very rough. So that is
Yes.
the sandpaper. दिव्या समझ में आ रहा है? Are you able to understand?
Yes, sir.
Okay. Hold it with pair of tongs. So this is tongs. I think I'm not sure in 10th standard in your school do you have that laboratory or not. So when you will go to 11th or 12th standard, you'll be having lab. Okay, there you will see all those tongs, magnesium ribbon, and then sandpaper. So what you have to do, you have to hold the magnesium ribbon with your tongue. Suppose
Don't know
this
what is
is
lab also, sir.
sorry laboratory.
Yes, sir.
Yeah. Suppose this is magnesium ribbon. So tongue will be something like this. Okay. You have to hold it like this with the help of tongue. So that you should not touch with your hand this magnesium ribbon. Tongue will be something like this. You have to hold magnesium ribbon with this tongue. Okay. That's what they have written here. Is this clear?
Yes, sir.
Yes, sir.
Okay. I will ask questions. So everyone listen very carefully. And this is very interesting. Okay. Burn it using a spirit lamp. So this is a spirit lamp, this one. You could say this now. This is a spirit lamp. 1 minute. This area is your spirit lamp. Okay. And this is your tongue. And this one is your magnesium
ribbon.
ribbon.
Magnesium ribbon.
Got it? Okay. Burn it using a spirit lamp or burner and collect the ash. What is the meaning of ash?
The
The black
residue
color.
of burning. Yeah.
Hmm.
When we
You all have
burn
seen
some.
ash?
Yes, sir.
You all have seen?
Yes, sir.
Tumna, have you seen rash?
Yes, sir.
ओके दिव्या, आपने रैश देखा है? रैश क्या होता है? दिव्या, ऐश ऐश
Yes,
देखा
sir.
है आपने? ऐश ऐश क्या होता है? आपने देखा होगा कभी जब लकड़ी को जलाते हैं तो लास्ट में जो बचता है ना, उसको राख भी कहते हैं, उसी को ऐश कहते हैं। देखा है?
Yes, sir.
हाँ, ये वही है, उसी को ऐश कहते हैं, ASH, ऐश. So, as burner and collect the ash so formed in a watch glass. So after you burn it, okay, that magnesium ribbon, you could see something dotted here in the. It's coming here. It's visible. So
Yes,
this is ash. So if you see, like it is getting collected here.
yes,
So
sir.
this is ash. Okay. Watch glass. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? Burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. So now the ash, what you're getting here, so that is what they're telling here. Okay, you must have observed that magnesium ribbon burns with a dazzling white flame. So when you will burn the magnesium ribbon, it will give that white color flame. Okay, and changes into a white powder, which will change into a white powder. Okay, that is what I am showing you here. This is something like a white powder. So when you're burning magnesium, right, what you will get? Ash, which is nothing but a white powder. Okay, this powder is magnesium oxide. So white powder, what you're getting here, this is your magnesium
Oxide.
oxide. Very good. It is formed due to the reaction between magnesium and oxygen. So how you got this? It is because of the reaction between magnesium and oxygen present in the air. So you have taken here magnesium ribbon. Now, when you're burning it, it is getting in contact with the oxygen. So magnesium plus oxygen, what you're getting? Magnesium oxide, and that is coming downwards and it is getting collected here. So this is your magnesium oxide, and this is a good example of any chemical reaction. So the chemical reaction is happening here. You started with magnesium. Finally, what you have? Magnesium oxide. Okay. Is this clear?
Yes,
Yes,
sir.
sir.
Okay. So it is formed with the reaction between magnesium and oxygen present in the air. So how you form this magnesium oxide? It is because magnesium and oxygen is reacted. They have taken, they have reacted, and that has given the magnesium oxide. Okay. Now, the another activity, take lead nitrate solution in a test tube. So what you have to take now? Lead nitrate, okay, in a test tube. Okay. Lead nitrate solution in a test tube. Add potassium iodide solution to this, what you observe. Okay, they are asking here, take this two solutions, lead nitrate and potassium iodide solution, and then check what will happen. We'll discuss it. And then you have another example as well. Take a few zinc granules in a conical flask or test tube, add dilute hydrochloric acid or sulfuric acid to this, and handle the acid with care. Do you observe anything happening around the zinc granules? We will discuss all these things. Okay. From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. The first point is change in state. So whenever chemical reaction will take place, what will happen? The state will change. What is the meaning of a state? If something is solid, it will convert into liquid. Sometimes the liquid will convert into gas. Okay. So that is what the state will change. So whenever chemical reaction happens, this is the first point, the state will change. Clear?
Yes, sir.
Okay. Krishna, are you listening to me?
Yeah, yes, sir.
You're doing something else.
I'll do something else, sir.
Okay. Change in color. What is the meaning of this?
Like the color of this product changes when two reactants or two substances mix. Like,
Whenever the chemical
yeah,
reaction will take place, the color will also change. So what will be the first change?
change in state.
Change in state. What is the meaning of a state?
From solid to liquid, like from
Hmm.
gaseous to liquid
Their
or
texture.
solid. Yeah.
Okay.
Yes, sir.
And second thing, what will change?
Change in color.
Change in color. So whenever chemical reaction take place, these all things will happen. Change in state, change in color. So what are the different states? Solid, liquid,
gas,
gas,
aqueous.
aqueous. Yeah. Now, evolution of a gas. So whenever chemical reaction will take place, you will see some gas will be evaluated. Means vaporized or something, you will see like gas will be there. Okay. And then change in temperature. Temperature will also change. A very good example of change in temperature is when you're adding like a detergent or surf in water, and if you will insert your hand into that water, have you observed that it will be a little bit warm? No?
No, sir.
Try today. Try today. Okay, take some water in a mug and add some detergent, maybe Surf Excel, Ariel, or Tide, anything, and then insert your hand in it. So you will observe that little bit temperature will increase. So that is what you will feel that, oh, this is warm. So it means the temperature will increase there. Okay. Is this clear? So these
Yep.
all things happens whenever the chemical reaction will take place. Yes, Sumna, you're telling something?
No, sir.
Okay. As we observe the changes around us, we can see that there's a large variety of chemical reactions taking place around us. Yes, around us, if you will see, large number of chemical reactions are taking place. And that's what we have seen in the beginning, right?
Yeah.
We'll study about the various types of chemical reactions and their symbolic representation in this chapter. So that is what we're going to study in this chapter, about the different chemical reactions and what will happen when a chemical reaction will take place. So these 4 points we have discussed so far. So whenever a chemical reaction will take place, one out of this, or maybe two, or maybe three, or all these four changes you will observe when a chemical reaction will take place. Hope it is clear.
Yes, sir.
Yes, sir.
Okay. Now, chemical equations. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. In the first example, what we have seen here, you are burning magnesium ribbon, right? So what has happened there? The magnesium ribbon is burnt in oxygen. So magnesium ribbon plus oxygen, it has given magnesium oxide. So that is what they're showing from this example. Magnesium plus
Plus
oxygen
oxygen
is
gives
giving you
magnesium
magnesium
oxide.
oxide. So this is the reaction. Is this clear?
Yeah, yes, sir.
So this magnesium and oxygen are known as reactants. And finally, what you got here?
Product. Magnesium oxide.
Magnesium oxide. So that will be the product. So what
Okay.
is reactants and what is product? Is that clear?
Yeah,
Yes.
yes.
So what is reactant here?
Reactant is
Reactant.
magnesium and oxygen.
Oxygen. And what is the product?
Magnesium oxide.
Magnesium oxide. Very good. So this is again a good example of chemical reaction. Hope this is clear.
Yes, sir.
Yes, sir.
Okay. The substances that undergo chemical change in the reaction 1.1, magnesium and oxygen are the reactants. The new substance is magnesium oxide formed in the reaction as a product. That is what they're telling here. Magnesium and oxygen are the reactants. Finally, you got magnesium oxide. That is the product. Hope this is clear.
Yes, sir.
Yes, sir.
A word equation shows change of reactants to products through an arrow placed between them. So this arrow, what you are showing, what we are seeing here, this shows that the reactants are getting changed into product. So
Products.
that is the meaning of this arrow. Okay.
Yes, Yes, sir.
The reactants are written on the left hand side with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. So here in this chemical reaction, what you have in the left hand side?
The uh,
Reactants,
reactants.
right? So reactants will be on the left hand side, okay?
Yes, sir.
And product will be on the
Right hand.
Right side.
right hand side. So this is clear?
Yes, sir.
Yes, sir.
Okay. So now what will be on the left hand side? Reactant or product?
Reactant, sir.
Reactant. Okay. Uh, Divya, on the right hand side, what will be there?
Product.
Product. Good. Okay. This is clear?
Yes, sir.
Yes, sir.
Okay. Now, writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if you use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written as like this. So what they are telling you here, okay, in the previous example, they have shown, okay, this is example of a chemical reaction, magnesium plus oxygen equals magnesium oxide, right?
Yes, sir.
Okay. So now you all have studied about in the periodic table, you might have studied about the chemical formula or symbol,
Yes, sir.
right? So magnesium symbol is Mg. So that is why you have to remember that magnesium symbol is Mg. So that is why instead of magnesium, they have written Mg here. Is this clear?
Yes, sir.
Yes, sir.
So this magnesium is Mg. Okay. Oxygen symbol is O2. Is this clear?
Yeah, yes, sir. It's clear.
Yes,
Okay.
sir.
And then magnesium oxide is MgO. These are all things you have to remember. This is important. This is the symbol of it. Symbol of magnesium is
Mg.
Mg. Symbol of oxygen is
O2.
O2 and magnesium oxide
MgO.
MgO.
So where did
Is this
two
clear?
go?
Tell
Like
me.
O2, right? So where did two
Hmm.
go? Like when we're writing the chemical equation.
That we will discuss. That is known as balancing a chemical equation. Good question. We'll discuss it after it. That
Okay.
is known as how to balance the chemical equation. A very good question you have asked. We'll discuss it at a later point of time.
Okay, sir.
Okay. So this is clear to everyone.
Yes, sir.
Divya and Sumna, is this clear?
Yes, sir.
Okay. So like this, you have to remember in chemistry, a lot of things which you have to remember. Okay. So similarly, you have to remember this as well. Okay.
Yes, sir.
Now the next one. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2 is skeletal chemical equation for the burning of magnesium in air. That is what they're telling. That this is not a balanced chemical reaction. They're just showing you, okay, you have magnesium and you're burning this with oxygen, you are getting MgO, right?
Yes, sir.
So this is just like a skeletal. This is not the exact chemical reaction because we have to balance it. That's what we'll study after this, how to balance a chemical equation. Like how Manaswini asked question here. Okay, here in oxygen we have 2, but in the right side we don't have 2 with oxygen. So this is not a balanced chemical reaction. So now after this we will study how to balance it. Is this clear so far, everyone?
Yes,
sir.
sir. Sir.
Understood now?
Yes, sir.
Okay. Now balanced chemical equation. Now we will study how to balance a chemical equation. Okay.
Sir, now only I'll come.
Recall.
In 2 minutes I'll come.
Sorry.
Sir, I'll come in 2 minutes. Sir.
Okay, sure, no problem. So now recall the law of conservation of mass that you studied in class 9th. In class 9th, you might have studied about the law of conservation of mass. What was that? Do you remember?
Yeah. Yes, sir. Mass can neither be created nor destroyed
Hmm.
in a chemical reaction.
Okay. So mass always remains constant, right? That is what we have studied in the class 9. Mass can neither be created nor destroyed in a chemical reaction. So in the chemical reaction, the mass will always be constant. You cannot change it, you cannot modify it. Okay. So this point is important. Mass is constant. You can neither be created nor destroyed in a chemical reaction. The meaning of this is, suppose on the left hand side, the mass is 1 kg. Suppose. Then on the right hand side as well, the mass will be 1 kg.
1 kg.
Yeah, this is known as law of conservation. You cannot change it, you cannot modify it. Now this is clear?
Yes, sir. Yes, sir.
Okay. That is, the total mass of elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. That is what I told. A total mass on the reactant side must be same the total mass on the product side. So on the reactant, if you have 2 kgs, how much will be on the product side?
2 kgs.
Right?
Yes, sir.
Okay. So Divya, is this clear?
Yes, sir.
क्या समझ में आया बताओ मुझे. What you understood, explain me.
Mass is neither can be created and nor be destroyed.
मास को ना ही क्रिएट कर सकते हैं ना ही डिस्ट्रॉय कर सकते हैं. ठीक है. रिएक्टेंट
Yes,
में, यहाँ पर रिएक्टेंट क्या है इस इक्वेशन में?
reactant MgO.
Mg है और O2 है रिएक्टेंट. Mg मीन्स मैग्नीशियम, O2 मीन्स ऑक्सीजन. So this is reactant. And what is product? MgO is
MgO.
product. ठीक है. MgO क्या है? प्रोडक्ट है. And Mg plus O2 is the reactant. Okay, that is, the total mass of the elements present in the product of a chemical reaction has to be equal to the total mass of the elements present in the reactants. It means in the reactant, if you have 5 kgs, product will also be 5 kgs. Got it? In other words, the number of atoms of each element remains the same before and after a chemical reaction. It means the number of atoms what you have before the reaction, it should be same after the reaction as well. Hence, we need to balance a skeletal chemical reaction. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation. So now we will study how to balance a chemical equation so that the number of atoms on the reactant side should be same as the number of atoms in the product side. Okay. So we have taken the example of this one, zinc plus sulfuric acid. It will give zinc sulfate plus hydrogen. So tell me here in this example, Sumna will answer. What are the reactants here?
Zinc and sulfuric acid, sir.
Very good. Divya, what are the products here?
Zinc sulfate hydrogen.
वेरी गुड. जिंक सल्फेट प्लस हाइड्रोजन क्या है दिव्या? प्रोडक्ट है. बहुत अच्छा, वेरी गुड. तो देखो एरो के बाद जो भी होगा ना दिव्या, वो प्रोडक्ट होगा. ऐसे समझ लो, ठीक है?
यस सर.
ओके. और एरो के पहले जो होगा लेफ्ट साइड में, वो क्या होगा?
रिएक्टेंट.
वेरी गुड, वेरी गुड, वेरी गुड, ऑसम, वेरी गुड. ठीक है. तो नाउ जिंक, व्हाट इज द सिंबल ऑफ जिंक? Zn. देखो कल मैं पूछूंगा, टुमारो आई विल आस्क ऑल दिस थिंग्स. ओके. व्हाट इज द सिंबल ऑफ मैग्नीशियम?
Mg.
Mg. सिंबल ऑफ ऑक्सीजन?
O.
O2.
O2.
Symbol of magnesium oxide?
MgO.
MgO. Very good, very good. Okay. Similarly here, what is the symbol of zinc?
Zn.
Zn. Zn क्या है? Symbol है zinc का. Okay. Symbol of sulfuric acid? Formula of
H2.
sulfuric acid? H2SO4. So H2SO4, this is known as
Sulfuric acid.
sulfuric acid. I will request everyone unmute. Krishna कहाँ गया? Krishna, unmute yourself. Divya, आप भी unmute करो. I want everyone to be on unmute. Unmute रहना, ठीक है? If you have some background noise, then you can mute. ठीक है? So Zn plus H2SO4. So H2SO4 is sulfuric acid. So what you will get here? ZnSO4. What is this ZnSO4?
Zinc sulfate.
Zinc sulfate. What is this H2?
Hydrogen.
Hydrogen. So what is the reactant here?
Zinc plus sulfuric acid.
Zn and H2SO4 is the reactant. Okay. And what is the product?
Zinc sulfate plus hydrogen.
Zinc sulfate plus hydrogen is the product. This is clear?
Yes, sir.
Okay, good. Good, good, good. Are you finding it interesting or boring?
Interesting.
Interesting here? Okay, good. Now, let us examine the number of atoms of different elements on both sides of the arrow. Okay, what you have on the LHS in this chemical equation, what you have on the left hand side?
Zinc.
Zinc and
Sulfuric acid.
sulfuric acid. What do you have on the right hand side?
Zinc sulfate plus hydrogen.
Zinc sulfate plus
Hydrogen.
hydrogen. Very good, very good. Now we will check the number of atoms. So here zinc has how many atoms?
1.
1. So zinc has 1 atom. Okay. Hydrogen has how many atoms here?
2 atoms.
See here 2 is written. No, can you see this? Is it visible?
Yes, sir.
This is visible.
Yes, sir.
So hydrogen has how many atoms?
2.
2 atoms. Okay. Sulfur, S means sulfur.
One
S is having how many atoms? 1 atom.
One.
O, oxygen is having how many atoms?
4 atoms.
4 atoms. ठीक है? You all have periodic table?
Yes,
No,
sir.
sir.
No. Okay. Tomorrow I want everyone take a printout, color printout of periodic table. Or if you will go to any stationery shop, no, you can buy from there. They will
Sir, I know
inspire to.
one, like all of it, 1 to 20.
You know means all the elements from 1 to 20. Great, great, great. So tomorrow everyone has to purchase that periodic table. Okay. And what you have to do, where you are sitting, or means you are studying. Okay. Paste it somewhere in your study room. Okay. Clear?
Okay. Sir.
Divya, you will ask Kundan. He will buy a periodic table for you. Okay. And you have to paste it in near your study table. In that periodic table, you will find all the elements and the formula. Okay. So
Yes,
oxygen
sir.
has how many atoms?
4. 4, sir.
4. Very good. Now, this is on the reactant side. Now we will check on the product side. Now, product side, zinc has how many atoms?
1. 1.
1. So it is written 1 here. Now, hydrogen has how many atoms here?
2. 2.
2. So it is written 2 here. Okay. Sulfur has how many atoms?
1.
1. It's written 1 here. Now, oxygen has how many atoms?
4.
4.
4. It's written 4 here. Got it?
Yes, sir.
Okay. Now check one by one. On the left hand side and on the right hand side, are the numbers same? So zinc, how many atoms you have on the left hand side?
1.
1. On the right hand side?
1.
1.
1. It is same or not?
Yes, sir.
Yes, sir.
It is same. Okay. Coming to hydrogen, how many atoms you have on the left hand side?
2 atoms.
2. Right hand side?
2 atoms.
2.
2 atoms. It is same.
Yes, sir.
Yes, sir.
Okay. Similarly, sulfur and oxygen are the same.
Yes, sir.
Yes, sir.
Okay. So because the number of atoms on the left hand side and on the right hand side are same, so this is known as balanced chemical equation.
Sir,
So we
we
can tell
balance
that
the
this
chemical equation to satisfy the law of conservation of mass, right, sir?
correct. Let me complete first. So this is an example of balanced chemical equation. Is this clear?
Yes, sir.
Yes, sir.
Okay, good. Just okay. Now we will see the next example. Okay. This is our next example. So here, what we have, let us try to balance the following chemical equation. Now this is Fe. Fe is the symbol of which element?
Iron.
Iron.
Iron. Okay. Fe means
Iron.
iron. H2O means
Water.
Water.
water. Okay. And then when you're performing this chemical reaction, this is Fe, this is H2O, and then you are getting there Fe3O4 plus H2. Okay, is this clear?
Yeah, yes, sir.
Now, what are the reactants here?
Iron
Fe
and water.
H2O.
Iron and H2O.
Water.
Fe means
Iron.
Iron.
iron. H2O means
Water.
water. Fe3O4 means
Iron oxide.
iron oxide. Good. Okay, and this H2 means hydrogen. How many elements you have on the reactant side?
3.
3 elements. Oh, sorry. Means how many reactants? How many reactants are there?
Two.
This is Fe and H2O, right? And product, you have 2 products, right? Okay.
Yes.
Now, we will check whether this is a balanced equation or not. Okay, now let's check it. So what they are telling, first of all, to balance the chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. First, what you have to do, you have to keep each and every reactant and product in a box. That is why you see they have drawn a box here. Got it?
Yes, sir.
Then list the number of atoms of different elements present in the unbalanced equation. Now, Fe, how many atoms of Fe you have in the reactant side?
1.
1. Okay. On the product side,
3.
3. So is this balanced?
No.
sir.
No, this is not balanced. Okay. Let's check next one. H. Hydrogen. How many atoms do you have on the left side?
2.
2 on the right side?
2.
2. So is hydrogen balanced?
Yes, sir.
Okay. What about oxygen? How many atoms? Okay, 1 minute. Divya will tell. Divya, how many oxygen you have on the left side?
1.
1. Right side में कितना है? How many you have on the right side?
4.
4. Is this balanced?
No, sir.
No. Very good. Very good. Clear to everyone?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Very good. Now we have to balance it. Yes,
Yes, sir.
we have to balance it. It is often convenient to start balancing with a compound that contains the maximum number of atoms. It may be a reactant or a product in that compound in a structural element which has the maximum number of atoms. Okay, now we will try to balance it. So to balance, what we'll do, we'll start to balance the oxygen. We'll start with the oxygen atoms because oxygen has maximum number of atoms. In the
Yes.
product side, oxygen has how many atoms?
Product oxygen 4.
4.
4, right? And the reactant side,
1.
1. So what we will do in this oxygen to balance the oxygen, what they are telling, initially in the reactant, we have 1 oxygen. So we'll multiply this with 4. Okay? We'll multiply this with 4. That is what they are doing here. If you see here, 1 minute. This Fe plus H2O, they have written Fe plus. In this H2O, they multiplied with 4. Can you see this 4 here?
Yes, sir.
Why they are multiplying with this 4 to this H2O? Why?
To equal it with the oxygen, sir. In the
Correct.
product.
Because on the right side you have 4 oxygen. So if you multiply this oxygen with 4 on the left side, you will get 4 oxygen on the left side as well. That is why they are multiplying with 4. Clear?
Yes, sir.
Tumna, Divya, Krishna, clear है सबको?
Yes,
Yeah,
sir.
yes, sir.
Okay, now I have a question. Are you ready?
Yes, sir.
Yes, sir.
Okay, this question is for Sumna.
Okay,
Suppose, Sumna, if I have 3 oxygen on the right hand side. Suppose. How many
Okay,
oxygen?
3.
On the right hand side. Then on the left hand side, you will multiply with which number?
3, sir.
3. Very good. Okay, clear. So why we are multiplying with 4 here?
To equalize both LHS and RHS.
Because on the right side we have 4 oxygen. So we want 4 oxygen on the left side as well. That's why we are multiplying this with 4. Okay, and that's why we have written 4 here, right? Okay. Now, after this, what will happen? Fe and hydrogen atoms are still not balanced. So oxygen is balanced. Okay, but what about Fe? Yeah, how many Fe you have iron you have here? Left side?
1,
Only 1. On the right side?
3.
3. So is it balanced?
No, sir.
No. Okay. So which one we have balanced as of now?
Oxygen. Oxygen.
Only oxygen we have balanced, but we have not balanced Fe. Okay. What about H? Hydrogen, have you balanced hydrogen?
No, sir.
No. Okay. We'll check how to balance it. Fe and hydrogen atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 in the RHS. So what we have to do, we'll start with the hydrogen atoms. So here we have how many hydrogen atoms? Tell me. We have written
4.
4 here and this H is having 2. So it will become 4 into
8
2,
hydrogen atoms. 8
8. So how many hydrogen atoms you have on the left side?
8, sir. 8.
8. On the right side, how many you have?
2.
Only 2. So what you will do here to get 8?
Multiply with 4. 4.
Correct. So that is why here as well they multiplied with 4.
Okay.
Is this clear?
Yes, sir.
Are you understanding it?
Yes, sir.
Okay. Now, what we have balanced? Hydrogen is balanced.
Oxygen.
Hydrogen is balanced, guys.
Yes, sir.
Oxygen is balanced.
Yes, sir. Yes.
Okay. What is not balanced here?
Iron.
Iron. So now we have to think how to balance iron. Okay. So how many iron you have on the left side?
1. 1.
One. How many you have on the right side?
3.
3.
Three. So what you will do to balance it?
Multiply 3.
Multiply 3 to
3 on
iron.
the reaction
Correct.
side of iron.
So see what they have done. They multiplied by 3. Clear to everyone?
Yes,
Yes,
sir.
sir.
Sure.
Yes, sir.
Okay. So now this is the final one. 3Fe plus 4H2O, Fe3O4 plus 4H2. This is now the balanced equation. Have you understood this?
Yes, sir.
Okay. Divya, clear?
Yes, sir.
Okay. So we will stop here and we will continue tomorrow. But tomorrow I will ask all these questions to you. Okay. I will ask all these questions. What is reactant? What is product? How to balance the chemical reactions and all those things. Okay.
Yes, sir.
Any question?
No questions.
No, sir.
Okay. So we will connect tomorrow at 6:45. Is that fine?
Yes, sir.
Okay, sir.
Yes, sir.
Okay.
Sir,
Tomorrow
is
also
there
we
any
will.
homework?
Sorry.
Is there any homework?
I will post it in the group. You have to balance few chemical equations. I will give that in the group.
Sir,
Okay, sir.
every class will be on 6:45.
6:45. Yeah.
Okay, sir.
Okay. After March, I will change it because still March Ramzan is going on. Okay. I have to go for prayer and many other things are there. That is why very hectic timelines. So from April, we will change the timings as per your convenience. Okay.
Okay, sir.
Okay. Chalo. Enjoy your day. Take care. Bye.
Bye, sir. Thank you, sir.
Thank you. Thank you. Bye. Bye.